discuss about how to connect the LDR sensor with the Arduino. So first, what is a LDR? LDR is a semiconductor material. The material is cadmium sulfide. It has the two terminal. This is the one terminal. This is another terminal. So look here. This structure is a zigzag structure. Why it is required? That to get the maximum resistance value. Here the resistance value at the dark position is in terms of mega ohm and in bright lightning is around 10 ohm. Now come to this circuit arrangement. This is the Arduino. Yes, this is an Arduino board. This is an LDR. It has two terminals. One terminal is connected to the power supply, that is 5 volt. The other end is connected to the analog input. So this is the resistance which is connected to the ground. Then this is the output side. This side is already you know that. Now what will happen if the light is decreases? That means the intensity of the light is decreases, the resistance value is going to increases, and the current is decreases, the device is going to off positions. If the light is increases, the resistance value is going to decrease, current is increasing, and the device become on. Now we are going for an virtual simulator. Just go to the web now. Now enter the website ThinkerCAD.com. You want to create a project now. Just click create project. If you are clicking that, a new project is going to open. Just click on this. So under this you have the options 3D design and circuit. We are going to simulate the circuit. Just click the circuit. A new page going to open now. So in this place you have to pick the component and place it. So what are all the things we are discussed in the previous slide? The same thing going to sketch it in this area. Once you are completed this circuit diagram, you want to write the coding for this operations. So for that, just go to code. Now this is the LDR. It is a analog signal. So first you want to measure or you want to assign as some variable. So just click variable. Just click. You can type the name LDR value. Yes. Now this is it will create a 3 block. That is, this is the variable name. This is set. This is change. So what block we record now? Because this LDR value, we are going to assign some value to the LDR. So you have to take this set block. Now this is a LDR value. So from where you are going to read the LDR values in the board? Just look here, this two connections. This part is connected to A2, that is a signal. This part is an ground line. So definitely ground we are not reading, we are reading the pin number A2 only. You want to set the here is an A2. But you could not directly type the A2 value here because it is a input. So go to the input block, and here is there are many blocks are available. Choose the block whichever is required for your project. Here we are reading the analog pin, so I am selecting the analog read pin and placing this place. and also this pin is connected to the A2 terminal, so you have to click this drop down menu and select A2. Now you can see that, so whatever the value is coming to the pin number A2, that is assigned to the LDR values. Yes, fine. Now I don't know what is the value the LDR is giving now. I want to print that value manually. So the print statement is an analog or digital. So where I have to print this value? I want to print this value in serial monitor. So for this I have the options print to serial monitor. Just to pick this block in the output block, under the output block. So this is a word, that is in here is the word is given. Instead of this you have to print your values. That is which value? That is LDR value you have to print. You just pick this box and place it here. Okay, so now the LDR value is going to print in the serial monitor. Yes, good. Now the input side is completed. Now coming to the output side, I want to glow the LED. For that it is an output, so go to the output. So you have to choose any one of this. Which one is suitable block to you? Here this is an analog values, because the LDR giving an analog input, depends upon this LDR value, this LED is going to glow. So definitely the output is an analog value only. So for this analog value, what I am going to do, that I want to choose suitable block here. So here set pin 3. So I am choosing this because all the PWM pin will come under this category. So here is pin number 3, 5, 6, 9, 10, 11. These are all the PWM pins. So I am choosing 3. Okay, I have chosen this pin value is 3. So I selected it, no problem. What the value have to display? That is the next problem. So it will be displayed. It is not a 0. I want to display the LDR values. Yes. So just to go to variable, just to take the block LDR and display it and place it. For the same thing, if you want to see the real Arduino code, you can look it here. So one more thing you have to bear in mind. So the analog input, which is going to read from 0 to 1023 only. Suppose if you have this analog value more than that, you have to do the mapping, that is minimum value to 0 and maximum value to 1024. So depends on your requirement. It may be any range, but it will be mapped to 0 to 1023 only. Now I am going to simulate this. Yes, it's started now. So I have to press this. Now this is the small wiper is going to display now. You have to adjust this wiper and you have to observe the output. It is a minimum position. The LED is glowing very little and is moving to an upper side, that is an increasing the intensity, it will glow brighter. Now I don't know what is the value of this LDR at the initial position and the maximum positions. I want to see that. So and also I given the one command line serial.print. So where I have to see that? Just again go to the code. You should not stop the simulations. Let it be as such. You just click the code. Now you see here serial monitor. You just click on that. It will show the values. So what is the value of your marker now? So it is an 679. Now suppose if I am adjusting this to some other positions, now you can see that 517. Yes. So by adjusting the wiper, you can see the result now. Yes. So it is maximum is 679 and the minimum is 0, but it's giving this 6. Yes. So in between this range only. So you need not require the mapping. Suppose instead of that it may be on some other value above this range, you can go for a mapping. Just look the serial monitoring output. We click on graph. Depends on my adjustment on the intensity, the graph is going to display it. Yes. Now adjusting this, you can see that. So I am setting to some values. It's a constant value. Yes, it's coming the constant value. Now I am reducing to some other value. Yes, is 395. Again I am moved to some other value. Yes, this is the graph. Now you can stop the simulations. Suppose if you want to save your work in social media, or you want to give this work to for some other person, ask the two options. One is a snapshot of your design. That means if you are clicking this picture going to download it in the your local drive. Suppose clicking the other options, it directly go to mail. Yes. Or this is the link. Yes. So I copied the link. So this link will be shared in any of this purpose. So even for Facebook or any tutorial class, you just give the link directly here and click it. Yes. Just paste the URL and your circuit going to open. This circuit is also editable by the other persons. They can simply click it, start simulations. So they will do what are the modifications you require. So be careful about sharing the URL of your work, because you maybe did some project, it will be auto saved. If you are sharing the URL, the other person may change your circuit diagrams, or they may be misplacing some components. It is a trouble to us to recheck again. So be careful in that one. Thank you.